In the previous video, we explored the Model Context Protocol and how it enables AI systems to connect to external tools in a standardized way. In this lesson, we shift from theory to practice and look at how these ideas appear in modern AI coding environments. We will use agentic coding as the setting so that we examine a practical example of an advanced agent and at the same time develop an understanding of what agentic coding means. Our goal in this video is, first, to give a brief introduction to the concept of agentic coding, and second, to look at concrete capabilities that become possible inside a real agent. To make these ideas concrete, we will use Cursor as the running example. Since it exposes both of these capabilities, we will focus on two features that connect directly to our earlier topics. The first one is MCP servers, which allow the coding environment to connect to external tools and data sources. And the second is cursor rules, which allow the user to steer the agent through explicit instructions and context shaping. By the end of this video, we'll have a practical view of what an agentic coding system looks like, how to think about working with it, and how to approach the new capabilities it offers. Let's begin. Agentic coding refers to a style of programming made possible within agentic software development environments. Terms like AI-assisted coding and vibe coding also point to the same shift towards systems where AI plays an active, collaborative role, not just suggesting the next line, but participating in the coding process. The key distinction lies in autonomy and scope. Traditional tools work with local context and suggest fragments. Agentic systems read entire code bases, understand file relationships, run commands, test and verify their own changes, and adjust behavior based on results, all without needing manual coordination from the user. Agentic coding tools appear in different forms. Some are standalone IDEs like Cursor and Windsurf, where agentic capabilities are built directly into the coding environment. Others, like Claude Code, are primarily command line tools, but also offer editor integrations such as a Visual Studio Code extension. GitHub Copilot functions as a plugin for existing IDEs, including Visual Studio, JetBrains, and others. It is also increasingly accessible via github.com and from the command line. There are other emerging tools at various stages of maturity, but they all point in a common direction: systems that aim to make the coding process more autonomous, responsive, and context-aware. Cursor is a modern integrated development environment, IDE, but unlike traditional IDEs, it functions as an agent. That means it doesn't just offer static features, it collaborates with the developer in a more interactive and autonomous way. In Cursor Editor on the left side of the screen, we see the familiar structure of a traditional IDE: files, folders, and a code editor. But what makes Cursor agentic is what happens on the right: a conversational interface that's always available. This is where you interact with the AI agent. You can brainstorm ideas, ask questions about the code base, and generate or modify code using natural language. Cursor also has full visibility across your entire project. It's designed to understand file relationships, follow dependencies, and manage changes that span multiple files. Crucially, it applies a range of context engineering techniques to control what goes into the context window, balancing visibility and efficiency so that the AI remains effective without being overwhelmed. In short, Cursor is a clear example of what an agentic IDE looks like. A development environment that combines traditional tooling with intelligent assistants that can navigate, reason about, and reshape code bases in a structured and context-aware way. It is an excellent example of an agentic AI system. Cursor's conversational interface offers multiple modes, each designed for a different kind of interaction or coding task. These modes let you tailor how the agent behaves, from passive Q&A to fully autonomous code edits. There are 4 main modes. The first is the agent mode. This is the most autonomous setting. The agent can explore the code base, make changes across multiple files, and refactor or build new features end-to-end. All tools are enabled. The second one is the ask mode. Use this for learning, planning, or asking questions about the code base. The agent stays read-only. It doesn't make changes, but can search and summarize relevant parts of the project. Only search tools are used here. The next one is the plan mode. This mode is useful when you want control before any changes happen. The agent creates a detailed plan, checks its understanding, and only proceeds after getting your confirmation. It supports all tools, but begins with a more cautious approach. And the last one is the custom mode. This is a flexible option where users can define their own workflows or constraints. It's suitable for specialized use cases and is fully configurable. Each mode helps define the level of autonomy the agent should take. That way, you can match the interaction style to the task, whether you're just exploring, carefully planning, or ready for the agent to take action. Planning is a great example of a practical agentic capability. In this case, we're asking Cursor to help us build a demo for the Figma MCP server. Rather than immediately generating code, the agent starts by creating a structured plan. On the right, we see the conversational interface being used to define the task and produce the plan. It includes a breakdown of steps, a to-do list, and space for the agent to clarify or ask follow-up questions if needed. On the left, the resulting plan is rendered as a markdown file inside the project, treated just like any other planning artifact in a normal development workflow. Certainly, we can do better development if we do better planning. And when agents help us plan more effectively, they support a more thoughtful and structured approach to building software. It also ensures that the human stays in the loop. The proposed steps can be reviewed, adjusted, and agreed before any code is written. This kind of oversight and collaboration is a crucial feature of working in an agentic environment. Once the plan is built, the tools specified in that plan become available to the agent. In this case, the build step included adding the Figma MCP server. This enables Cursor to interact directly with Figma design files as part of its agentic capabilities. What we see here is the Cursor settings panel under Tools and MCP, where the Figma server now appears alongside other MCP servers like SQLite, Browser, and File System, which had been added separately for other use cases and are also good examples for MCP servers. The Figma server can now be toggled on. Once enabled, it gives the agent the ability to fetch design data, extract code from dev mode, take screenshots, and access other metadata, all through a standardized tool interface. This is what allows the Cursor agent to act on the design in the next step. Now that the Figma MCP server is enabled, it can be used to take meaningful actions inside Cursor. On the left side of the screen, we see the Cursor agent interface. where the user simply drops in a Figma design link and asks the agent to build this. From there, the agent uses the tools exposed by the MCP server, like getCode and getScreenshot, to extract the UI structure, fetch assets, and generate a working React component, as our project is a React app, that matches the original design as closely as possible. The image on the right shows the original Figma design that the agent is working from. It's displayed in a browser window for easy comparison. This kind of workflow, where the user can describe a goal and the agent calls structured tools to move toward it, illustrates how tool use becomes a natural part of the development process. Leveraging a Figma design directly in code is now quickly and easily possible thanks to the standardization that MCP provides. In addition to MCP servers, which enable powerful scalable integration with external tools, another key area of agentic functionality lies in how the system manages context. Agentic coding environments like Cursor offer features that make it easier to guide, shape, and control what goes into the model's context window. This is crucial because the quality of an agent's decisions depends on what context it has access to. Some important features that support this kind of context engineering are rules. Rules let you define reusable instructions scoped to specific files or directories. For example, you can set coding standards, architectural guidelines, or behavioral constraints that apply across parts of your codebase. Memories are used to remember relevant background information between sessions, such as project goals or user preferences. And custom commands. These allow you to save and reuse prompts that perform specific tasks. You can create custom shortcuts for code review, merge conflict resolution, test generation, or any repetitive prompt you want to share with your team. Together, these features allow the user to stay in control of the agent's behavior, helping steer how the model thinks and what it pays attention to, without having to write every prompt from scratch. In Cursor, both rules and custom commands play a key role in shaping how the agent behaves, and both can be defined in two ways, either through the settings interface or by storing them as files directly in the project. In the top half of this slide, we see the rules, memories, and commands settings panel. From here, users can create global or project-specific rules and commands to guide the agent's behavior. In the bottom half of the slide, we see an example of a command file, specifically a command that helps automate creating a pull request using the GitHub CLI. This is a reusable instruction that can be triggered at any time, for example, by typing /PR in the chat. On the left, we also see a rules folder in the project directory. Rules stored in this way are automatically scoped and applied based on the file paths and naming patterns, and they help enforce specific instructions like coding conventions or structural guidelines. Together, this setup gives developers fine-grained control over how the agent behaves, making the system more predictable, reusable, and aligned with team or project needs. In this video, we explored what agentic coding means in practice. We used Cursor AI as a concrete example, a modern IDE that integrates AI as a coding assistant. We saw a number of capabilities that make this possible, including MCP servers, which make it easy to connect to external tools and serve services like Figma, rules and commands, which let users shape how the agent behaves and what context it works with. Together, these features show how agentic coding environments allow developers to plan better, build faster, and stay in control while collaborating with increasingly capable agents.